This video is about finding the sum of interior, sum of exterior, each interior and each exterior of a polygon, and finding the number of diagonals in a polygon. So before we start finding our sums, we need to talk about two more vocab words, concave and convex. So concave, if any part of a diagonal is on the exterior of a polygon. So here, to connect a vertex to a vertex in a diagonal, we see that that is outside of our shape. And concave means no diagonal contains points on the exterior of the points. Another way to think about this is that all of the diagonals are inside our polygon. So if we look at the pentagon here and we draw in our diagonals, we will notice that all of the diagonals fit inside the pentagon without going outside. So let's get to our equation. So the first one is the sum of interior angles. So the sum of interior angle equation is 180 times n minus 2, where n represents the number of sides. So determine the sum of interior angles of the polygon. So if we have a heptagon has 7 sides. So we would do 180 times 7 minus 2. We can just type that in the calculator all at once, and we get 900 degrees. Name the convex polygon that has the sum of interior angles. So now we have the sum, we need to find the number of angles. So 180 times n minus 2 equals 1080. We can distribute the 180 and add 360 to both sides. So 180n is equal to 1440. We can divide both sides by 180, so n is 8. A shape with 8 sides is an octagon. In number 2, we can set this equal. 3,780 equals 180 times n minus 2. So we get 3,780 equals 180 minus 360. We can add 360 to both sides. So 180n is equal to 1,440. When we divide by 180, n is 23, so this is a 23gon. Our next is the sum of exterior angles. So the sum of exterior angles, all the angles outside always equal 360 degrees. It doesn't matter how many sides it has. So 121gon with 121 sides is still going to have the sum of exterior to be 360. For the number of diagonals, our equation for the number of diagonals is n times n minus 3 divided by 2, where n is the number of sides. So if we have a 300gon, we would have 300 times 300 minus 3 divided by 2. When we put that in our calculator, we get 44,550 diagonals. If we're given the number of diagonals, we want to determine how many sides we have. So with 14 diagonals, we have n times n minus 3 over 2 equals 14. To get rid of the 2 in the bottom, we're going to multiply both sides. So n, I'm also going to distribute the n, so n squared minus 3n equals 28. So this is going to be a factoring problem. N squared minus 3n minus 28 equals 0. So two numbers that multiply to negative 28 and add to negative 3. We have n minus 7 and n plus 4 equals 0. So n is 7 and n is negative 4. We can't have a negative side length, so we just have 7 sides, which is a heptagon. In number 7, we have 90 diagonals. So we're going to have n times n minus 3 over 2 equals 90. We would multiply both sides by 2, so n squared minus 3n equals 180. We're going to move everything to the n squared side, so n squared minus 3n minus 180 equals 0. What multiplies to negative 180 and adds to negative 3? So we have n minus 15 and n plus 12 equals 0. So n is 15 and negative 12. We can't have negative side lengths, so this is a 15gon. So regular polygons means that all sides are congruent and all angles are congruent. The next two formulas then are only going to apply to regular polygons where all of the angles are congruent. So to find each exterior angle, we're going to take the sum of interior angles, and then we're going to divide by the number of sides. So if we have a 15 gon, we have 180 times 15 minus 2 divided by 15. So that gets us 2,340 divided by 15 angles. So each angle is 156 degrees. In a nonagon, that is 9 sides. We have 9 times n minus 2 divided by 180 times n minus 2 divided by 9. So that gets us 1,260 divided by 9, 140 degrees. If you are given each interior angle, we want to find the number of sides. So we're going to set that equal to our formula. 180 times n minus 2 over n equals 160. We can multiply both sides by n and distribute. So 180n minus 360 is equal to 160n. Negative 360 equals negative 20n. When we divide, we get 18. So this is an 18 gon. In number 11, 180 times n minus 2 over n equals 144. Multiply both sides by n. So 180n minus 360 equals 144n. We can move the variable to the other side. Negative 360 is equal to negative 36n. When we divide, n is 10. So this is a decagon. To find each exterior angle, we would do the sum of exterior angles 360 divided by the number of sides. So in number 12, we have 360 divided by 15, so each angle is 24 degrees. In a hexagon, that's 6 sides. 360 divided by 6 gets us 60 degrees. If we are given the exterior angle, we can also find the number of sides. So we have 360 over n equals 15. We can multiply by n. 360 equals 15n. We divide by 15, we get 24, so that is a 24 gon. We also have 360 over n equals 5. We can multiply by n, so 360 equals 5n. When we divide, we get 72, so this is a 72 gon. Our last bonus formula then is that each interior plus each exterior is going to equal 180 degrees. This is because if we have a shape, the interior angle and the exterior angle together are going to form a straight line, and when you form a straight line, that's 180 degrees. So a way to make it a little bit easier on ourselves is that if we know the interior angle, we can find the other angle. So in number 18, we want to find the number of sides and the exterior angle. So our exterior angle is going to equal 180 minus 150, which is 30 degrees. To find the number of sides, it's definitely easier to work with your exterior angle. So we have 360 over n equals 30. We can multiply by n. 360 equals 30n. Divide. So n is 12. So this is a dodecagon. In 19, if our interior angle is 135, each exterior angle is going to be 45 degrees. So we have 360 over n equals 45. 360 equals 45n. When we divide, n is 8. So that is an octagon. If we are given the exterior angle, we want to find the interior and the number of sides. So if the exterior is 120, we can subtract from, or is 20, we can subtract from 180, we get 160 degrees. When we go to find the number of sides, though, I still want to work with the exterior angle because it's easier math. So 360 over n equals 20. 360 equals 20n. When we divide, we get 18 sides, so that is an 18 gon. If we have an exterior angle of 60, our interior is 120. we have 360 over n equals 60. 360 equals 60n. When we divide is 6. So that is a hexagon.